Good morning, everybody. I am Dr. Vidya from Computer Science Department. Today we are going to see the remaining networking and internetworking devices. That is a continuation of yesterday's class. The last class we saw the networking devices, repeaters, bridges and gateways. Today we are going to see the routers. Okay, what is the routers? Routers are used to connect two or more networks. For routing to be successful, each network must have a unique network number. Let us see. The device A via network through the router will pass the information to the device B. See in the diagram, the green color shows that it occupied the physical layer, data link layer and the network layer. So routers are used to connect two or more networks. Say routers in the internet. So how that blue color indicates the routers and its pointers, and the yellow color shows that topology, networks, ring topology and bus topology. See the diagram shows the connectivity of the router. Okay. Routers act like station on a network multi-home. What is its goal is learning how to get from here to there. That is process of discovering, selecting and employing the path from one place to another or to many others in the network. See, we are going to collect the which path is going to the best one. Arriving the destination, here we are going to consider the routes, the direct route which is the shortest path, or reliable route, cheap route, safe route and the scenic route. So the routers are used to find the shortest path or the best path. Routing concepts we are having, least cost routing is the base one, and we are going to concept adaptive routing, non-adaptive routing, and packet lifetime we are going to see. We are having the two types of routing algorithms. One is distance vector routing and the linked state routing. With that, the Dijkstra algorithm is also there. So the first one we are going to see the what is least cost routing. See the diagram. The least cost routing, we are going to use the hop count and the link of quality, speed, congestion and link medium. See the diagram. We are having the routers A, B, C, D, E, F. And the networks are ID 14, 78, 23 like that. Here the A neighbor is B, F and E. So through the network ID, it can connect with the B. A can connect with the neighborhood with the 78 network ID to F. And A can get the connectivity with E through the network ID 23. And we are having the adaptive and non-adaptive routing. Non-adaptive means static, does not changes once fixed in the beginning of the router. Adaptive means the dynamic, always changes and finds a new path whenever it goes. We are going to calculate the packet lifetime also, that is TTL, time to live. Routing concept, the first one we are going to see the distance vector routing. Here we are going to use the routing information protocol. Each router uses the broadcasting to send its entire information to its neighbor for every 30 seconds. We are having three rules here. The first one is each link is assigned a weight. Distance to the destination is the sum of the weights along the path to the destination. Each router sends its entire information about entire network to its neighbor. Neighbors are other routers with a direct link to it. Information or second rule is information are shared periodically even if nothing has changed. The best path is based on the least number of hops. Information are shared periodically even if nothing has changed. Eventually, every router will learn about the other routers on the network. Slow coverage. It takes longer for all the routers to receive all information. This RIP, Router Information Protocol, is used by the TCP IP IPX. So this is the diagram. The network 14, 78, 23. Router A is the neighbor B with 14 network ID. Router A has the neighbor F with the network ID 78, neighbor E with the network ID 23, like this. See, the rules are explained here. A, neighborhood, B, F, E. I periodically send my knowledge about whole internet to my neighbor. Similarly, F to A, C to B and D, D to C and E, and E to A and B. This is the table. Convert a distance vector routing table. Its format is network ID, its cost, and next O. See the table, network cost, next O. A having the network 14, 23, 78, ID. Similarly, the B, similarly C, D. In E, the neighbor is network ID is 8 and 23. Hope count. Next is we are going to calculate. This is the distance vector routing concept diagram. Hope you can all follow this. Okay, now the process is going on. Now A received from B. So its neighbor is 14, 55 and hope count is, see, 14, 55, hope count is 1. And A's whole table 14, neighbor is 14, 23, 78. Received from B, A. So that's why we are going to add one hope. So after the adjustment, the B will become 14, 55. Increase the hope count 1, 1, 2, 2, B. So this is after adjustment B's table, and we are going to combine the A and B table. 14, 14, 1, here 14 2B, 23, 1, 55, 22, 78 according to the ascending order. We are going to write and we are going to combine. Now we are going to eliminate the same one. We are having the neighborhood 14 twice, and we are going to select the smallest cost, that is 14, 1. 14 2B is discarded, then 23, 52B, 78. So this is called the SU table according to the distance vector routing. Hope you can follow this. Similarly, we are going to find for all the table A, B, C, D, E and F. The distance vector routing algorithm is updating the algorithm. If the advertised destination is not in the routing table, the router should add the advertised information to the table. If the destination is in the routing table, we are going to check if the next hope field is the same. The router should replace the entry in the table with the advertised one. Let us note that even if the advertised hope counter is larger, the entry should replace the entry in the table because the new information is invalidates the old one. If the hope field is the not same, then the advertised hope is smaller, then the router should replace the entry. If the advertised hope count is not smaller, the router should do nothing. Okay. That's all the routing vector concept. Hope you can follow this. Next we are going to see the linked state routing. Any doubt you may ask me. So in the class we saw the least cost routing, adaptive, non-adaptive, what is packet lifetime, the routing algorithm, These are the distance vector routing. Thank you students. We will continue in the next class.